Hi everybody, welcome back. The most exciting thing this week was probably that I got to take one of my research heroes out for drinks. Having been a professor for only 4 years, I'm still always amazed when people whose work I greatly admire and whom I've been citing in many of my articles actually agree to meet with me. Now, this person happened to be in town for a conference, and he asked me a question about something that I kind of glossed over in the previous videos, the fact that I started doing research in elementary school fractions learning, and then I moved into undergraduate chemistry learning. So he asked me, how did I get from fractions to chemistry? And this story is actually also about how I got interested in learning with visuals in the first place. The story starts when I was doing an internship at a research group at Carnegie Mellon, and I was tasked with developing an educational technology for fractions learning. So I had to make a decision about which visuals to include. And there is in fact some controversy about which visuals are most helpful for students. Some people say that pie charts are intuitive, for example, because you can talk about fractions in terms of sharing pizza, so you can connect to students' prior real-world experiences. Others say that number lines are best because they connect to whole number concepts. So perhaps because an argument can be made for each of these visuals being the best, most fractions instructional materials actually use multiple visuals. But to my surprise, there was at the time no study that tested whether students do actually learn better if they work with multiple visuals than if they work with just one visual. So I conducted that study. I compared students who worked with only one visual, like a number line or only a pie chart, to students who got multiple visuals, so number lines and pie charts. And all students did, of course, see the fraction symbols. And then I was also interested in whether helping students connect the symbols to the visual would help them learn. So half of the students got prompts from the technology to explain how the visual shows the numerator and denominator that you see in the fraction symbol, and the other half of the students did not get those prompts. And what I found entirely blew me away. Students who got multiple visuals but no prompts actually showed the lowest learning gains. That was surprising to me because it's actually common practice to give multiple visuals without prompts for students to relate them to the symbols. But then the students who got multiple visuals with the prompts showed the highest learning gains. So this result got me interested in supporting students learning with visuals, because it suggests that unless students understand how each visual shows information, then they'll fail to benefit from multiple visuals, even though common educational materials use multiple visuals. So that is what got me started on looking at how best to support students learning with visuals. And I did several studies on this on elementary school fractions learning. And then when I found that we need to support explaining as well as the intuitions that I talked about in the last two videos, then I started wondering whether this is specific to fractions learning or whether it might be a general principle across multiple domains. So I chose chemistry for my next studies because visuals are very prevalent in chemistry education too, but on all other levels it's an entirely different domain. It's science rather than math, it's undergrads rather than elementary school students, and it's a different setting too, so not in a school classroom but in a college chemistry course. So now you know why I do research across different domains. And so far, what I've found in my research makes me think that we do need to support students in explaining visuals and in developing intuitions about visuals in any domain that heavily relies on multiple visuals.